So you can tell that, as we said, all these EM waves are going to be obeying our C is equal to frequency times lambda. You can tell that here, if you have a longer wavelength, if your wavelength is high, then your frequency is going to be lower. Okay, and here when you have a shorter wavelength, you're going to have a higher frequency. Like I did in the video, that to maintain our speed as C, then an increase in wavelength can only mean a decrease in frequency, and an increase in frequency can only mean a decrease in wavelength. So this is important that you understand. So let's look at these kinds of electromagnetic waves in detail. Let's look at each of them one by one. Okay, so we have our radio waves, and these are the kinds of waves that we use for our radio and TV signals, for our cell phone signals, and also our Wi-Fi. And that is they have a wavelength of 1 times 10 to the power negative 1 meters, and they have a frequency of 3 times 10 to the power 9 hertz. So that is what we have for our radio waves there. Microwaves follow, and these are used in microwaves and radar, GPS satellites, and also in telescopes. You can see the wavelength there, ranging from 10 to the power negative 1 to your 1 times 10 to the power negative 3, and the frequency there is also given a range there, from your 3 times 10 to the power 9 hertz to your 3 times 10 to the power 11 hertz. So those are some of the properties here. Infrared waves, they are used in heat sensors. The infrared waves exist at a slightly higher wavelength and slightly lower frequency than visible light. So these are the ones that are close to the visible light, and the prefix infra means below or further on. So infrared means slightly lower frequency than red, or further on along the spectrum than red. So that's what it simply means. So you can see here, and then we get into our visible light range. So these are terahertz here, terahertz, and these are the wavelength is given in nanometers there. Okay, then we have our ultraviolet light. These are the harmful rays that come from the sun. They exist at a slightly lower wavelength and slightly higher frequency than visible violet light. The prefix ultra means beyond, so ultraviolet means a slightly higher frequency than violet or beyond violet. Okay, we have our X-rays, which are used by doctors, can also be used to destroy cancer cells, also used in some telescopes. We have our gamma rays. These are found in nuclear reactions, the radiation from radioactive waste, and gamma rays have the highest energy of any EM wave, and therefore the most dangerous. So it's important that you understand that these properties of the electromagnetic spectrum, and also general properties of your electromagnetic waves. So we'll talk about light in detail for our O-level IGCE. We'll talk about light, we'll talk about reflection, we'll talk about refraction. So you can hang on for such discussions, and I'll see you and meet you in the next video.